Hello viewers, welcome back to my channel, and in this video we're going to solve a Bernoulli differential equation. Kindly subscribe if this is your first time visiting this channel. So we have theta prime of t, which is equal to 3 multiplying theta cube minus theta all on 125. So this being a differential equation given, how are you going to identify that it is Bernoulli's differential equation? Now when you say Bernoulli differential equation, we know that it's just an upgrade on linear differential equation. So the term theta cube here, now the dependent variable here is theta. So if you get a dependent variable which has a power greater than 1 in it, then we say that that equation is Bernoulli differential equation. So let's quickly go through and see how we solve this. Kindly watch this video to the end and don't forget to like as well. So to start this, we have to put it in the standard form or standard Bernoulli differential equation form. So that is generally in this form. We have y prime plus p of x y is equal to g of x multiplied by y to the power n. So the term y to the power n here makes it Bernoulli's differential equation. So our goal here is to convert this to this form so that we apply the necessary method. So doing that, we're going to have theta prime of t to be equal to 3 theta cube over 125 minus theta over 125. So now we have still not made it in the standard form because this term here, p of xy, is here, so I have to bring it to this side. I'm going to get theta prime of t plus theta over 125 is equal to 3 theta cube on 125. So I can say that at this point it is in the standard form and I can apply the necessary formula to do it. Dividing my workspace. Now in Bernoulli differential equation, what you do is that you divide through by the term here, that is y to the power n, you divide through by it. So here I'm going to divide through by theta cube, and that is going to give me theta to the power negative 3 multiplying theta prime of t plus theta to the power negative 2 over 125, and this should be equal to 3 on 125. So I have divided through by this theta cube, therefore here it becomes an inverse, here 2 divided by, so you get 1 minus 3 giving us theta to the power negative 2, and this is equal to 3 over 125. So at this point we make a little substitution here, that is y, or you choose any variable. So here let's choose u. Let u to be equal to this term you have here, that is theta to the power negative 2. To do that, you differentiate u and you get u prime to be equal to, applying differentiation, negative 2 theta to the power negative 3, that is you subtract 1 from it. Then since it is implicit, you add theta prime. So we can see that this whole function here is similar to what we have here, so we can make a subject here. So I'm going to get theta negative 3 theta prime to be equal to u prime over negative 2. So here I come back making my substitutions. Wherever I see this, I put this, and wherever I see theta to the power negative 2, I put u. So I'll end up getting u prime over negative u prime over 2, then plus u over 125 is equal to 3 over 125. So at this point we have converted it to the linear, but in the first order linear the coefficient of the u prime should be 1. For that reason I'm going to multiply through by negative 2 to cancel the half I'm having here. So I get u prime standing alone, u prime of, let's say u prime of t standing there alone, plus minus, I'm multiplying through by negative 2, so minus 2u over 125 is equal to negative 2 multiplying 3 over 125. So I'll come down here, I'll get u prime of t to be minus 2u over 125 to be equal to negative 6 over 125. So at this point, it is in the linear form. So what do I have to find? I have to find the integrating factor. So finding the integrating factor, mu of t to be equal to the e to the power integral of the coefficient of this u, that is negative 2 over 125 dt. And this is simple, and it will be given e to the power negative 2 on 125 integral of dt. So integral of dt, we assume that there is 1 here, and that is going to give us a t. So this will be simply e to the power negative 2t over 125, and this is our integrating factor. Now let me come up here, and as I've gotten my integrating factor, I'm going to multiply through our differential equation here by 8. So I'll get u prime of t by this integrating factor e to the power negative 2t on 125 as we have here. Then this plus the integrating factor again, e to the power negative 2t over 125, multiplying the expression negative 2u over 125, negative 2u over 125, all is equal to negative 6 over 125, multiplied by the expression e to the power negative 2t over 125, like that. This becomes a product rule, so we get u multiplying the expression e to the power negative 2t over 125, all prime, to be equal to negative 6 on 125, multiplying the expression e to the power negative 2t over 125 nicely. So once you get this, our aim is to find u. So I just take integral on both sides. So I bring my integral sign, then integral sign. Here, the integral will cancel the derivative here. So I'll be left with u multiplied by e to the power negative 2t over 125 to be equal to, this is a constant, it will come out, negative 6 over 125 multiplied by e to the power negative 2t over 125. So I'll bring my integral here, then dt. So at this point, I'm going to integrate this section. To do that, this is a simple integral. You just make u to be equal to the whole function here. So applying our calculus 1, I'll straight away write the answer, and I'll get this, the coefficient of this dividing the whole expression. So I get 125 over negative 2 multiplying negative 6 over 125, then integral of e to the power, let's say p dp. I assume that I made a substitution of p, so this from calculus 1. So this will give us, this will cancel this, and this will go here, 3 e to the power p, then plus c, where my p is the whole function here. So this is equal to 3 e to the power negative 2t over 125 plus c, and this should be equal to the expression u multiplying e to the power negative 2t over 125, like this. So making u the subject, I simply get 3 e to the power negative 2t over 125 over e to the power negative 2t over 125 plus c e to the power 2t over 125. The reason I made it 2t because it will be inverse. So at this point, I'm going to get u to be equal to, this will cancel this, and I'll get 3 plus c e to the power 2t over 125. So once I get this, from the beginning I made a substitution that u is equal to theta to the power negative 2, and our question, the dependent variable given was theta prime. So I have to make our substitution here. Theta to the power negative 2 will be equal to 3 plus c e to the power 2t over 125. Therefore, theta to the power positive 2 will rather be 1 over the expression 3 plus c to the power c multiplying e to the power 2t over 125. So theta will then be equal to the square root of the expression 1 over 3 plus c e to the power 2t over 125. And we know that the square root of 1 is 1, so theta is simply 1 over the expression square root of 3 plus ce 2t over 125. So this is simply the answer for this Bernoulli's equation I have here. I hope watching this video is helpful. Don't forget to like. Thanks for watching.